So hello everyone, Aniket here this side. So today we will be discussing one of the question that is based on binary search algorithm. So in this question it is given that we need to find the floor of an element in the sorted array. So here if we'll talk about the definition of floor, then it is said that let's say we are having an array that is sorted like 1 4 5 6 8 9, and also a target element is given. Let's say the target element is x and it is 5. So it is given that if the target element is found in the array, that is it is here, then our answer will be 5 itself. This is one of the case, and the second case is that if it is not found, for example if my target element x equal to 10, and as it is not present in this array, then we need to return. So listen properly, this is the actual definition that they are trying to explain or they are trying to give. It is if the actual element is not present, then we need to return the greatest element that is smaller than target element x. So here for example, greatest element smaller than target element, so suppose x equal to 10. So as the first condition is satisfied, that is it is not present in the array, and according to second condition our answer will be 9, because it is the smallest element which is less than x, and also it is the greatest among 1 4 5 6 and 8. So let's see the approach. So in this we can use various or I can say a linear searching algorithm. So let's our array will be suppose 1 2 4 5 and 7. So we'll just iterate from here, that is I equal to 1. If I will talk about index base, then I equal to 0 till n minus 1, and I will check if the target element x is present in this array, then I will return array, that is array of that ith index. If not, this was first case, if the element is present in the array, and if we'll talk about second case, that is if not present, and we need to return the greatest element smaller than x. Okay, so what we will do, we will suppose this is the vector, and here our target element is, suppose if I say the target element is 10. So if in the array 10 is not present, then our answer will be 9. So we'll iterate from 1 till size, and if this element, that is nums of I, is less than target, as we know it is not present, so it will be less than target as it is sorted array. So we'll just return that element and we'll break out from this loop. Okay, but if we'll talk about the time complexity, then as we are iterating through the array, it will be big O of n, and the space complexity will be as we are not creating any extra space, it will be O of 1. Now let's talk about the optimized approach, that is using binary search. So as we know, the time complexity of binary search is log n, and here we are not using any extra space, so space complexity will be big O of 1. So isn't it quite good approach and efficient in terms of time complexity and space complexity? So let's discuss the approach. So first of all, we are creating a start index that is 0 and n index that is nums dot size minus 1 that is last index, and this answer is the variable which will be written at last, that is our answer. So we will check if start is less than equal to end. It means if suppose array is this 1 2 3 4 5 and initially I is pointing at here, that is 0, and end is pointing at here. So till these both are not crossing each other, for example this will move here and this is move here, so it is valid till here, till these both pointers collide or actually it present at one place or at one index, till that it is valid. So we are creating a mid, that is start plus and minus start by 2, and here the main reason behind taking, we can also write start plus end divide by 2, but here I am writing end minus start by 2 to overcome or to solve the integer overflow. So if we'll talk about the condition, then if nums of mid equal to target, then we will return simply the element which is present. It means this is the case when the element is present in the array. Okay, and if nums of mid is less than target, for example if I am 1 2 4 5 9 and 10 and it is asked to find a, suppose, okay, so it's 5 7 10 and it is asked to find, suppose target is x equal to 8, then if nums of mid, for example initially the mid will be 0 plus 1 2 3 4 5 divided by 2 which is equal to 2.5, so we will take floor value, so it will be 2.2, this is 0, this is 1, this is 2, here mid will be here. Now as mid is less than our target, that is x, from here we can see that this is mid. 1 minute, for example from this we can find that our mid value was 2 and 0 1 and 2, this is 2. As we know from this we can see that our nums of mid, that is 4, is less than target, that is 8. Okay, so we have to move here and rightward direction. So what we'll do, we'll store this answer in, or the element in a variable answer as I have discussed earlier, and we'll do start equal to mid plus 1. So now start was pointing, now start was pointing here, so it will become mid plus 1, so it will come, so this start will come here, that is here, and again we'll check if mid is less than target value, yes it is less, so again we'll store the answer here and start equal to mid plus 1, so again it will come here till 7. So after coming to 7 you will again check if it is less than, so answer equal to mid and start again equal to mid plus 1. When it will come to 10 we know that it is greater than, so it will become end minus 1, so here we are doing end equal to mid minus 1, so middle value will be shifted to the left side. So in this way, this is the this was the code. See, for example here we are making a vector which is containing element 1 2 3 4 7 9 11. Now our key is 10, that is target is 10, so as it is not present, so we will pass nums in the final floor answer, that is that is function, and the key that is required. So here what will happen, here first mid will be, this is 0, this is 1 2 3 4 5 6, so 0 plus 6 divided by 2 equal to 3, so our initial mid will be here. Now as it is less than, so it will become start plus 1, again start plus 1, but as this 9 is greater than 10, so sorry, as 9 is less than 10, so our final answer will be 9, because as the floor is defined as the nearest greatest element smaller than target element x. So I hope you like the content, and if you like it, please like, share and subscribe. And if there is any doubt, mention in the comment section. And if you want to contact me personally, you can see my LinkedIn profile in description. Thanks for watching. Have a good day.